Hi everybody, welcome back another serverless Java application demo. So in this demo, I'm going to showcase how to trigger the serverless Java deployment pretty much easier and quickly using a bunch of the tools. This is a really second demo using Knative and OpenShift as well as KNFunk. Let's get started. In the previous demo, we were using Quarkus and the Tecton pipeline, but this demo, we're not going to use Quarkus. Instead, we're going to use Spring Boot, one of the native Java framework, and also the source-to-image build based on OpenShift Radar and Tecton. So the reason why I'm going to talk a little bit about that just a little bit later. Let's get into the demo, how it works. Okay, first of all, we're going to create a new project using keyenfunk command line. Just in case you didn't have a chance to watch a first video, trigger a remote serverless Java development into Quarkus using Quarkus and using Tecton. So let me try to real quick explain keyenfunk. Keyen is a knative command line which allows you and developer to manage and deploy and build your application as a serverless function on top of Kubernetes cluster. So KN function, aka KN function command line, allows you to create and build, deploy your application regardless of Java or any polyglot language platforms such as .NET, Python, Go, and TypeScript, etc. Really more focus on Java, specifically Spring Boot application. We're going to create a new function named Spring-Fun in the runtime Spring Boot. And then we also trigger method by cloud events, just like the same behavior by Quarkus application example in the previous demo. You can also trigger by HTTP protocol as well. All right, just create a new project. And then let me change it to a working directory and then open this project using ID tool, for example, VS Code. Now let's take a real quick what the project looks like. And then here's the Spring Cloud function because Spring Cloud function is a known practice how to develop Cloud function on top of the Kubernetes cluster, but also hyperscaler such as Google function, Azure function, and Amazon Lambda things. So it automatically generates the simple function like a Maven project using Java 17. And then here's a few dependency related to my Spring function application. In the Spring, the application just starting an event application here, pretty much is simple, and then process messaging. And then this is just the Spring controller, and then you just print out the cloud event. So in case you never have heard about the cloud event before, so cloud event is one of the CNCF project to manage more standard event format across many different types of messaging platform. So sometimes you want to be your platform just prefer to use a JSON format to generate, consume, or process and produce your messaging across a cluster. Sometimes, but the other system just prefer to use prototype or binary. So how to transform, among others, messaging format infrastructure? Cloud event actually solve the problem whenever you create a cloud event messaging format. Any kind of platform actually process and which means consume and then process to messaging, which is more like a standard way to stand up event-driven architecture with serverless and specifically Kubernetes. Okay, it's pretty simple. And then let me go to Funk YAML. This is the most and important thing when they generate a new function project using key and func command line. So this is all manifestor how to define your serverless function. First of all, the function name, the Spring Fun, the runtime, Spring Boot, and the registry and image will be automatically updated when I run keyenfunk build and deploy. And the invocation by cloud event, and then there are a few build environment variable because keyenfunk allows you to build container image as a function using build packs or source to image by OpenShift. So not yet for Tecton pipeline. You can actually call Tecton pipeline to remote to build and deployment your application, just like a previous Quarkus demo video. but we have a little bit lack of functionality, like a source to image, basic image and S2I assembly at this moment. When you trigger Tecton pipeline to build and deploy remotely your Spring Boot application from local to remote Kubernetes cluster, even if your Kubernetes cluster already installed Tecton pipeline and Knative operator stuff, but it will end up failure because there are some source to assembly file is missing right now. And hopefully it's gonna be improved soon enough. But in the meantime, we're gonna just deploy it using source to image, which is more simple. However, it's still you have consuming a bunch of the resources on your local machine because you're gonna build this application from your local and deploy it to Kubernetes. So that's the reason why we're not going to use a Tecton pipeline, just like we already did in the previous demo, trigger a remote to serverless Java deployment on top of the Kubernetes. And then you can also, there are health endpoint. It's a default actuator endpoint by Spring Boot application, which is a really good feature to make sure the application ready to process a request. And then now I'm going to build my application just to make sure and verify the function capability. So using kmfunc build, and then I point to my container registry query.io. You can set any container registry if you want. And then one thing is using Quarkus, you don't need to specify builder image at this moment. However, we don't have any specific builder image for Spring Boot at this moment. That's why you have to set up the builder image explicitly in the command line here, like OpenJDK 17. And now I'm going to download all necessary Maven dependency and the build application. And now just automatically create a new container image. This is my local. I didn't push this image into container registry. And when I go back to func YAML file on my local file system, it automatically updated based on command line result, which is cool. Now let me try to find out the container image, and then let me try to run that container image locally to verify the functions. And then you can see the Spring Boot just started. And then I'm going to open a new terminal window and then change the right directory because I'm going to use kmfunc command line, which is should be running on the root directory in the project. Let me try to change the target endpoint localhost and then data Daniel O on Spring Boot. And now you can see Daniel O Spring Boot. When I go back to Spring Boot terminal, there are the same logo here, input Daniel O Spring Boot. And then I'm going to stop the local environment. And here's my developer sandbox. You can go to developers@redhat.com and then navigate developer sandbox menu, and you can sign in the developer program, which allows you have Kubernetes cluster and a bunch of the tool like a dev space cloud IDE for free. You're going to use that cluster for free next 30 days. And after the next 30 days, you can actually reactivate your cluster environment. But not just cloud environment, but also there are many kind of tutorial, essay, video, documentation. It will teach you to learn how to develop a bunch of your business application, not only Java, but also Node.js, Python, and Go onto the Kubernetes cluster. I'm going to try to use that cluster as well. And I switch it back to admin console, but I don't have admin permission now, but I can still see what kind of operator installed in developer sandbox. There are many kind of developer operator already installed. Today I'm going to use OpenShift Serverless based on Knative. So you don't need to install OpenShift Serverless when you use developer sandbox, which is really cool. And then I'm going to try to deploy the application using one single command line, kmfunc and deploy in the Serverless. And then it automatically just packaging and then just push the container registry inside the OpenShift container registry and then back to the OpenShift developer console and topology view. It's a new function just ready to start up right now. It takes a little bit some time. And then back to the local terminal window, and then you can see Spring is just starting. So if you already watched the first video to deploy Quarkus application using Tecton pipeline for remote deployment, it's really faster than Spring Boot. It's just like a less than 1 second to start up when you deploy application. But as you can see, it takes like a 5 seconds to start up, even if the same application. That's really Quarkus is faster than any other Java framework at this moment. Okay, the Spring Boot just starting, and then you can see the function logo. And then let me try to go into Spring Boot logs. And the Spring Boot is just starting without any exception error. In the meantime, the knative serving will scale down your application to 0 as long as you don't have any natural incoming traffic, which is a 30-second by default time period. So it's terminating as like a all scaled down to 0. And then let me try to invoke again. But in this time, I'm going to change my endpoint from localhost to actual route URL on my OpenShift cluster in Dev Sandbox. Changing my data, Daniel O Spring Boot on OpenShift Serverless. Okay, let me enter and then hit the URL. It literally opened the Spring Boot. And then but it takes some time. Again, it's a little bit slower than Quarkus. Quarkus is a start out like in a second, but it takes like a couple seconds. And now Daniel O Spring Boot and OpenShift serverless, and you can actually find the same message when you go into pod logs. Maybe you don't care the startup time, like a 1 second or 4 seconds, doesn't matter. But this is a very simple REST API. However, if you wanted to put in the more business logic on your single function and running on Kubernetes, and then it's really following to cold start strategy, just like Amazon Lambda. Sometimes your end user needed to waiting for more than 5 seconds to start up. In the meantime, they can only see the white blank web page, and then they literally just leave the page with some not good experience on your web server systems. So that's the reason why the fast startup time really matter when you design and develop and deploy serverless function, specifically Java application on top of the Kubernetes. All right, and let me go back to topology view. It's running on, and then it will scale to down to 0 in the next 30 seconds if you don't have any incoming network traffic. Let me know if you have any question. I'm more than happy to address, and thanks for watching.